So we're going to continue with conditional statements, and we're going to talk about conditional statements being true or false and what that really means. So a conditional statement has a truth value. So truth value of either true or false. That just means that a conditional statement can be true or it can be false. To show that a conditional statement is false, you need to find just one counterexample. And so you find a counterexample where the hypothesis is true and the conclusion is false. Something else that we need to look at is, remember how we said we have a P and then we have not P? Well, that's called a negation. Doesn't necessarily mean it's negative, it just means that it's the opposite. So if it is, then it's not. If it's not, then it is. And we'll see that in just a second. And you already know that that's written with the little squiggly line and P, and it's read as not P. So the negation of a true statement is false, and the negation of a false statement is true. So let's take a look at how negations work. So our P, our hypothesis, says school is fun, and we want to write the negation of that. So the negation of P would be that school is not fun. Obviously not true, right? School is the most fun thing ever. But let's try another one. So the negation of P, so P says it is not sunny outside. Well, the negation of P would be that it is sunny outside. So we went from is not to is. So we're going to determine if a conditional statement is true. If it's false, we're going to give a counterexample. And remember, for it to be true, we need for the hypothesis and the conclusion to be true. If the hypothesis is true and the conclusion is false, then that's a false statement. So if two angles are acute. So by true, we mean, could two angles be acute? Is that a possibility? And yes, that's definitely a possibility. So our hypothesis P and our conclusion Q, our hypothesis P is true. Two angles are acute. That's fine. Then they are congruent. Well, that's not fine, because we could have an angle that's 20 degrees, an angle that's 30 degrees. Both are acute, which makes the hypothesis true, but they're not congruent, which would make the hypothesis false. So this is a false conditional. Our counterexample would be right here, 20 and 30 degrees. So if you divide an integer by another integer, so divide an integer by another integer, that's our hypothesis. Can you do that? Sure you can, right? You can do 1 divided by 3. That's an integer divided by another integer. The result is also an integer. That's the Q. And notice this one doesn't have a then. Sometimes conditional statements don't have the word then written, but you understand that it's if this happens, then this happens. So the result is also an integer. Well, 1 divided by 3 equals 1 over 3, which is definitely not an integer. So that's false. So our conclusion, our hypothesis was true, our conclusion was false. That makes that a false conditional. And our counterexample, again, is right here. So we have a couple of conditional statements that are related to each other. They're called related conditional statements, and when they have the same truth value, they're called logically equivalent. Okay, and the logically equivalent statements are the conditional itself and the contrapositive. So if those both have the same truth value, if this one's true and this one's true, then they're called logically equivalent. And the other ones are the converse and the inverse. And again, if they both have the same truth value, then they're logically equivalent. So we're going to determine the truth value of each statement. We're going to write the statements and see which statements are logically equivalent. So if an insect is a butterfly, that's our P. Then it has 4 wings. That's our Q. Is that true or false? Well, an insect is a butterfly. That's possible, right? So that's true. Do all butterflies have 4 wings? You don't need to Google it. I'll help you out there. It's true. So the truth value of this statement, hypothesis true, conclusion true, this conditional statement is true. Now we go to our converse. If an insect has 4 wings, that's our conclusion. It's a butterfly. That's our hypothesis. So an insect has 4 wings. Well, sure, that can happen. That's true. Then it's a butterfly. Well, that's not necessarily true, because a dragonfly also has 4 wings, and it's not a butterfly. So this statement has a true hypothesis and a false conclusion. Therefore, it is a false statement. Okay? If an insect is not a butterfly, so there's that word not. So that is not P. Then it does not have 4 wings. That is not Q. So is it possible that an insect is not a butterfly? Sure. So that's true. That can happen. But does that necessarily mean that it doesn't have 4 wings? That's false, because again, our dragonfly, right? It's not a butterfly, check. But it doesn't have 4 wings. That's not check. So dragonflies do have 4 wings, so that's false, which makes our entire statement false again. Now the last part says, if an insect does not have 4 wings. So is that possible? Remember, this is not Q, then it is not a butterfly, not P. So is it possible for an insect to not have 4 wings? Sure. Then it's not a butterfly. Well, all butterflies have 4 wings, so if the insect does not have 4 wings, then it's not a butterfly. True. So true and true means we have a true statement. Okay? Almost finished. We're going to talk about something real quick called a biconditional statement. It's a combination of a conditional and its converse. Okay, the definition of a biconditional is it is the conjunction of a conditional and its converse. Okay, the symbol that we use for that, remember when we used just the arrow for the if-then, is we're going to use an arrow that goes both directions, and we'll see what that means in a minute. And another symbol that you might see is the 3 letters I, F, F. An example, we would say if P, then Q, but we can also say if Q, then P. That's called a biconditional statement. For a biconditional statement to be true, its conditional and its converse must be true. So we're going to look at an example because it's a lot easier just to see an example than to talk about it. So write the biconditional statement as a conditional and its converse. Then determine if the biconditional is true or false. If false, give the counterexample. So there is no school if and only if it is Saturday. So that if and only if is a key component of a biconditional. It means that this statement can be read both ways. We say there is no school if and only if it is Saturday. Well, you could also say it is Saturday if and only if there is no school. So our original statements are if there is no school, then it's Saturday. And our original converse would be, remember, this is our P, this is our Q. And the converse is if Q, then P. So if it is Saturday, then there is no school. Okay, what we need to determine is whether or not this is determine if the biconditional is true or false. And it's set up here, for a biconditional statement to be true, its conditional and converse must be true. So, conditional. If there is no school, is that possible? Of course. So it's a true hypothesis. Then it's Saturday. That's our conclusion. Well, that's definitely not true, because it could be Sunday. So a true hypothesis and a false conclusion gives us a false conditional. Now we look at the converse. It's Saturday. That's possible, right? So that's true. There's no school. That would also be true, because there's not school on Saturday. So we have a true converse. We have a false conditional and a true converse. But remember, for the biconditional to be true, both of them had to be true. So this is false. And our counterexample is Sunday. Could be Sunday. So that's it. See you tomorrow.